This is the EdExcel GCSE 9-1 Maths Higher Paper 1, which is a non-calculator paper, and this is from the 2022 series. Question number 1, we have to solve the inequality 7x subtract 27 is less than 8. Well, if we add 27 to both sides, 7x subtract 27 plus 27 is 7x, and this is less than 8 plus 27, which is 35. And at this point, if we divide both sides by 7, 7x divided by 7 will simplify to x, and this is less than 35 divided by 7, which is 5. X is less than 5. Question number 2. We have to write 124 as a product of its prime factors. Well, we begin with the 124, two numbers which multiply to give 124. We have 2 and 62. And the 2 is a prime number, but the 62 isn't. So the 62 we can further split up as 2 multiplied by 31. We now have prime numbers. 2 is a prime number, and so is 31. So when we come to write 124 as the product of its prime factors, we have 2 times 2 times 31, which is equivalent to 2 squared times 31. Question number 3. A delivery company has a total of 160 cars and vans. The number of cars to the number of vans is in the ratio 3:7. Each car and each van uses electricity or diesel or petrol. 1/8 of the cars use electricity, 25% of the cars use diesel, the rest of the cars use petrol. You have to work out the number of cars that use petrol. You must show all your working. First of all, we have the ratio of cars to vans being 3:7. We've got 160 vehicles altogether, and so having 3 to 10 tells us we have 10 parts in total, and so each part will be worth 160 divided by 10. That will be 16. So we have 16 for each box. And that's what we see here. And so to find the number of cars, that will be 16 multiplied by 3, which is 48. And to find the number of vans, that will be 16 multiplied by 7, which is 112. And so for electricity then, we have 1/8 of 48, and 1/8 of 48, that's equal to 6. Now we have 25% of the cars which use diesel, so for diesel we would have 48 multiplied by 0.25, a quarter of 48, that will be 12. And for petrol, well, we've got 48 in cars in total, 6 use electricity, 12 use diesel, so for petrol we would have 30. Question number 4. For part A, we have to write 1.63 times 10 to the minus 3 as an ordinary number. Well, we begin with this 1.63, and what we need to do is move this decimal place 1, 2, 3 to the left. So we end up with 0.00163. So we have 0.00163. Now for part B, we have to write 438,000 in standard form. First of all, for standard form, you will recall that's when a number is written in the form a times 10 to the n, where a is in between 1 and 10, and n is a whole number. So, if we have 438,000, the decimal point is here, and we need to move the decimal 1, 2, 3, 4, 5 to the left, and that leaves us with 4.38 times 10 to the 5. For part C of the question, we have to work out 4 times 10 to the 3 times 6 times 10 to the minus 5, give your answer in standard form. Well, what this is the same as, if we have 4 times 10 to the 3 and 6 times 10 to the minus 5 being multiplied by each other, we can rewrite this as 4 times by 6 times 10 to the 3 times 10 to the minus 5. 4 times by 6 is 24, and then I'm going to multiply this by 10 to the power of 3 plus minus 5. When I have the same base and I'm multiplying, I add the powers. So we have 24 times by 10 to the minus 2. What I want is this 24 to be a 2.4, but if that's the case, if I'm dividing the 24 by 10, I need to times the 10 to the minus 2 by 10, leaving me with 2.4 times 10 to the minus 1. Question number 5. Here is a regular hexagon and a regular pentagon. We've got this angle x, and we need to work out the size of this angle x, showing our working. Well, what we can do is find the interior angle of the hexagon and of the pentagon. Well, the interior angle of the hexagon, that will equal 180 multiplied by 6, because we've got 6 sides, subtract 2, and then we need to divide this by 6, and so 180 multiplied by 4 over 6, that's equal to 120. So this angle here is 120. Now the interior angle of the pentagon, that will equal 180 multiplied by 5 minus 2, we've got 5 sides, then divide this by 5, and it turns out we get 108. So this angle here is 108. We can now find out the angle x. Knowing that the sum of angles around a point is 360, we have x plus the 108 plus the 120. This is all equal to 360. And so therefore, x is equal to 132. Question number 6. We have to complete the table of values for y equals x squared minus 3x plus 1. Well, when x is equal to minus 1, we have y equals minus 1 squared, subtract 3 times minus 1 plus 1. And it turns out here we get 5. When x is equal to 2, y equals 2 squared, subtract 3 multiplied by 2 plus 1, and it turns out here we get minus 1. When x is equal to 3, y is equal to 3 squared, subtract 3 multiplied by 3 plus 1, and it turns out here we get 1. And when x is 4, y is equal to 3, rather y is equal to 4 squared, subtract 3 multiplied by 4 plus 1, which is 5. Here is the completed table of values, and then for part B we have to draw the graph of y equals x squared minus 3x plus 1 for values of x between minus 1 and 4. Well, here is the graph of y equals x squared subtract 3x plus 1 between minus 1 and 4. And then for part C, using a graph we have to find estimates for the solutions of the equation x squared minus 3x plus 1 equals 0. Well, we can see the graph crosses the x-axis here and here. We've got x equals 0.4, and we also have x equals 2.6. Question number 7. Here are two cubes A and B. A has a length of 3 centimeters and B has a length of 4 centimeters. Cube A has a mass of 81 grams and cube B has a mass of 128 grams. We have to work out the ratio of the density of cube A to the density of cube B. Give your answer in the form A to B, where A and B are integers. Well, the volume of A will equal 3 cubed, which is 27 centimeters cubed. The volume of B will equal 4 cubed, which is equal to 64 centimeters cubed. And knowing the masses, we can now find the densities. The density of A, we've got 81 divided by 27, that will be 3 grams per centimeters cubed. And the density of B, that's equal to 128 divided by 64, So it turns out here we get 2 grams per centimeters cubed. And therefore, the ratio density of A to density of B, that's equal. Question number 8. The table shows the amount of snow in centimeters that fell each day for 30 days. And what we have to do is find an estimate for the mean amount of snow per day. The first thing we can do is find the midpoints of each of these intervals. Here we have 5, here we have 15, here we have 25, here we have 35, and here we have 45. We can now work out the midpoint multiplied by the frequency. 5 times 8 is 40, 15 times 10 is 150, 25 times 7 is 175, 35 times 2 is 70, 45 times 3 is 135. So now that we've worked out the midpoint times the frequency, we can add together the midpoint times the frequencies. It turns out we get 570. And if we add the frequencies together, we get 30. And therefore, the mean is equal to 570 divided by 30, and it turns out we get 19. Question number 9. A cube is placed on top of a cuboid, as shown in the diagram, to form a solid. The cube has edges of length 4 cm. The cuboid has dimensions 7 cm by 6 cm by 5 cm. We have to work out the total surface area of a solid. Well, let's work out the various faces. Now, if we consider the cube, we would have all the faces apart from this bottom face here. So, if we were to work out the surface area of the cube, excluding the bottom face, so that's with no bottom, we would have 5 multiplied by 4 times by 4, and it turns out we get 80 centimeters squared. And then we can working out the top of the cuboid. Well, we've got the dimensions 6 by 7, so we have 6 times by 7, but then we need to take away this face here. So we need to take away that face, which is 4 times by 4. So here is the top of the cuboid. And if we work out what this is, we have 42 subtract 16, which is 26 centimeters squared. So now what we can do is find out the surface area of the bottom of the cuboid. That will equal 6 times by 7, and what we also have is the front and back So the front and back, that's equal to, well, I've got 2 multiplied by, because I've got the front and back, 7 times by 5. So I've got 35 times by 2, which is 70 centimeters squared. And then I've got the sides. That's equal to, well, I've got 5 times by 6 twice. So I've got 2 times by 5 times 6, 30 times 2 is 60 centimeters squared. So now I can find out the total surface area. The total surface area, we've got 80 plus 26 plus 42 plus 70 plus 60, and it turns out here we get 278 centimeters squared. Question number 10. The table shows some information about the profit made each day at a cricket club on 100 days. That's what we see here. And for part A, we have to complete the cumulative frequency table. Well, we start off with the 10. 10 plus 15 is 25. 25 plus the 25 is 50. 50 plus the 30 is 80. 80 plus the 5 is 85. And 85 plus 15, that's 100. Then for part B, on the grid we have to draw a cumulative frequency graph for this information. So here is the cumulative frequency graph, and now for part C, we have to use the graph to find an estimate for the number of days on which the profit was less than £125. Well, what we would have to do here is draw a vertical line up from 125 and then reading across, we see that we have 36, rather 34. And then for part D, we have to use our graph to find the interquartile range. Well, if we have 100 pieces of data, for the lower quartile reading from 25, we see that the lower quartile is 100, and for the upper quartile reading from 75, and then reading down, we see that here we have a value of 187.50, which would correspond to the upper quartile. And so therefore, for the interquartile range, we have the upper quartile subtract the lower quartile, and it turns out we get £87.50. Question number 11. Cormac has some sweets in a bag. The sweets are lime flavoured or strawberry flavoured or orange flavoured. In a bag, the ratio of the number of lime flavoured sweets to the number of strawberry flavoured sweets to the number of orange flavoured sweets is 94 to X. Cormac is going to take at random a sweet from the bag. The probability that he takes a lime flavoured sweet is 3/7. We have to work out the value of X. So, in total, we've got 9 plus 4 plus X. And of those, how many are lime? Well, that's 9 of them. And we know the probability of selecting lime is 3/7. So, for us to find out what X is, well, we've got 9 multiplied by 7, which is equal to 3 multiplied by 9 plus 4 plus X. So, what we see over here then is 9 times 7 is 63, and that's equal to 3 multiplied by 13 plus X. And if I divide through by 3, 13 plus X is the same as 21, which means X is equal to 8. Question number 12, we have to express 0.017 recurring as a fraction. You must show all your working. Well, what we will do is we will let X equal 0.117, 17, 17, etc. And because we've got 2 digits recurring, multiplying this by 100, we can then say that 100x is equal to 11.7171717, etc. And so, subtracting these, we see that 99x is equal to 11x is equal to 11.6, because these terms would cancel out. And so therefore, X is equal to 11.6 divided by 99, which is 116 over 990, which if I divide the top and bottom by 2, we end up with 58 over 495. Question number 13. A right-angled triangle is formed by the diameters of 3 semicircular regions, A, B and C, as we see in this diagram. And we have to show that the area of region A equals the area of region B plus the area of region C. Now, we begin by letting the diameter of the semicircle A equal A, that of B equal B, and that of C equal C. So if I add these to the diagram, then here I've got A as my diameter, I've got B here as my diameter, and here I've got C as my diameter. And what we need to do is find out the areas of A, B and C. Now, if we were to use Pythagoras, then using Pythagoras we have a squared equals b squared plus c squared. And what we can do is find the area of the semicircular region A, the area of the semicircular region B, and the area of the semicircular region B. So if we work out the region A, we've got a semicircle, so I've got 1/2 multiplied by, I've got pi times by the radius squared. So here my radius will be a over 2 squared. And if I work this out, it turns out we get pi over 8 a squared. And we can do a similar thing with the region of B and C. So similarly, the area of region B is 1/8 B squared, and the area of region C is equal to 1/8 C squared. Now, if I call this 1, then what we can do is multiply equation 1 through by pi over 8. So, multiplying equation 1 by pi over 8, well, I'd have a pi over 8 multiplied by a squared, and that will equal pi over 8 multiplied by b squared plus c squared. And so what we can do now then is see that pi over 8 a squared, which is the region of A, equals pi over 8 times by b squared plus pi over 8 times by c squared. The area of region A is equal to the area of region B plus the area of region C. Question number 14. Here is a speed time graph, and what we have to do is work out an estimate for the gradient of the graph at t equals 2. Well, at t equals 2, what we need to do is draw a tangent to the curve, something looking like this. And what we need to do now is find the gradient of this. So to find the gradient, what we can do is use the fact that the change in y over the change in x is the gradient. Here the change in y, we are going from 1 to 6, so the change in y is equal to 5, and the change in x is equal to 5.5. So therefore, for the gradient, we've got the change in y, 5, divided by the change in x, which is 5.5, and it turns out, if we work this out, we get 9 over 10, which is 0.9. So the gradient is 0.9. Then for part B, what does the area under the graph represent? Well, it would represent the distance travelled. Question number 15. A, B and C are 3 points such that AB equals 3A plus 4B and AC equals 15A plus 20B, and we have to prove that A, B and C lie on a straight line. Well, what we see here is that the vector AC is 5 times the vector AB. 3 times 5 is 15, 4 times 5 is 20. So we have 5 multiplied by 3A plus 4B for the vector AC. And so they are in the same line and in direction. Then for part B, DE and F are 3 points on a straight line such that DE equals 3E plus 6F and EF is equal to minus 10.5E minus 21F, and we have to find the ratio of the length of DF to the length of DE. Well, if we've got D, E and F on a straight line, then we've got here D, E and F. We know what DE is. That's 3E plus 6F. And we've got EF, which is minus 10.5E minus 21F. What we can do is find out what DF is by adding together DE and EF. So we add together 3E plus 6F plus minus 10.5E minus 21F. And so we can therefore conclude that DF is equal to minus 7.5E minus 15F. And if I factorize out A minus 2.5, then I have 3E plus 6F. And so therefore DF is equal to minus 2.5 DE. In other words, minus 5 over 2 DE. And so if we are considering the lengths, well, we've got DF over DE, that will equal (5 over 2), and that's because lengths are positive, and therefore the ratio DF to DE, that's equal to 5 to 2. Question number 16. A first aid test has 2 parts, a theory test and a practical test. The probability of passing the theory test is 0.75. The probability of passing only one of the 2 parts is 0.36. The 2 events are independent. We have to work out the probability of passing the practical test. Well, from here, we can see the probability of failing the theory test. So this is probability of failing the theory. That's equal to 1 minus 0.75, which is 0.25. Now what we need to do is find the probability of passing the practical test. If we let x equal the probability of passing the practical, then what we'll do is we'll create a tree diagram to model the situation. So here is a tree diagram. We've got passing the theory, failing the theory, and passing the practical and failing the practical, and we know that the probability of passing only one of the two parts is 0.36. So I could pass the theory, but then fail the practical, or I could fail the theory but pass the practical. So we've got 0.75 multiplied by 1 minus x, or we've got 0.25 multiplied by x. And this will equal 0.36. And this 0.36 would correspond to the probability of passing only one of the two parts. So what we need to do is find out what x is. So I've got 0.75 minus 0.75x plus 0.25x equals 0.36. So I've got 0.75 minus 0.5x equals 0.36. 0.5x then is equal to 0.39, which means x is equal to 0.78. So the probability of passing the practical is 0.78. Question number 17. Y is directly proportional to the square root of t. Y is 15 when t is 9. T is inversely proportional to the cube of x. T is 8 when x is 2. We have to find a formula for y in terms of x, give the answer in its simplest form. Well, from here we can see that y is equal to some constant a multiplied by the square root of t. And from here we can see that t is equal to some constant b multiplied by 1 over x, or dividing by x cubed. So we know that when t is 9, y is 15. So we have 15 equals a multiplied by the square root of 9. 15 equals 3a. A equals 5. So, knowing that a equals 5, we can therefore conclude y is equal to 5 multiplied by the square root of t. Now, what we can do is use the next condition when t equals 8, x is 2. So when x is 2, t equals 8. So we have 8 equals b over 2 cubed. So b equals 8 multiplied by 2 cubed. So b equals 64. And knowing that b equals 64, we can therefore conclude t equals 64 over x cubed. And now what we need to do is find a formula for y in terms of x, so we need to replace the t with 64 over x cubed. So if I call this equation 1 and this equation 2, we can substitute in equation 2 into equation 1. So I've got y equals 5 multiplied by 64 over x cubed square rooted. So I've got y equals 5 multiplied by 8, because that's the square root of 64, divided by x cubed square rooted. So y is equal to 40 over the square root of x cubed. Question number 18, we have to work out the value of 5 and 4/9 to the negative 1/2 multiplied by 4 and 2/3, all divided by 2 to the negative 3. We must show all our working. Well, let's first of all deal with this 5 and 4/9 to the negative 1/2. If I have 5 and 4/9, and if I'm raising this to the negative 1/2, then what we have here, if I convert this mixed number into an improper fraction, well, 5 times 9 is 45, plus another 4, that's 49. So we have 49 over 9 to the negative 1/2. And if I raise something to the negative 1/2, that's the same as reciprocating the fraction, so that's 9 over 49, and then raising this result to the 1/2. And if I work out what this is, it turns out 9 to the half is 3, 49 to the half is 7. And now if I deal with the 4 and 2/3, 4 and 2/3, that's equal to, well, I've got the 4 times by the 3, which is 12, plus another 3, that's equal to 14, and then I'm dividing this by 3. So if we work out this result here, well, we have 5 and 4/9 to the negative 1/2 multiplied by 4 and 2/3, and then I'm going to divide this by 2 to the negative 3. And if I work out what this is equal to, well, that's the same as 3/7 being multiplied by 14 over 3, and then dividing the result by 2 to the negative 3. So 3/7 times by 14/3, well, the 3's here simplify to 1, and 14 divided by 7 is 2. So what we end up with here then is 2 divided by 2 to the negative 3. And 2 is the same as 2 to the 1. So now subtracting the powers, we have 2 to the 1, subtract negative 3, so that's 2 to the 4. And 2 to the 4 is equal to 16. Question number 19, we have to solve 1 over 2x minus 1 plus 3 over x minus 1 equals 1. We have to give our answer in the form p plus minus square root q over 2. Well, what we can do is rewrite these over a common denominator. The common denominator will be 2x minus 1 multiplied by x minus 1. So we have 1 multiplied by x minus 1 plus 3 multiplied by 2x minus 1. And this is equal to 1. So, on the left hand side, we still have this 1 multiplied by x minus 1 plus 3 lots of 2x minus 1, and that will equal 1 multiplied by 2x minus 1 multiplied by x minus 1. So let's expand and simplify. I have x minus 1 plus 3 times 2x minus 3. So that will be 7x minus 4. And on the right hand side, 2x minus 1 times x minus 1. That's 2x squared minus 3x plus 1. And recognizing I've got a quadratic, I can take everything over to one side. So I've got 2x squared minus 10x plus 5 equals 0. Now, to solve a quadratic equation, we can use the quadratic formula. Now, here is the quadratic formula: x equals minus b plus minus the square root of b squared minus 4ac over 2a. A is 2, b is minus 10, c is 5. So substituting these into the quadratic formula, we have minus b, so that's minus 10, plus minus 10 squared minus 4 times 2 times 5, and then this is square rooted, divided by 2 times by 2. So, if I simplify this, I get 10 plus minus, now here I've got 100 minus 40, so that's 60. And then this is square rooted, and I'm going to divide by 4. Now, square root 60, we can simplify that. The square root of 60 we can write as square root 4 times square root 15, which is 2 root 15. So, what we have for x then is 10 plus minus 2 root 15 over 4. And if we attempt to simplify this by dividing the top and bottom by 2, we end up with 5 plus minus root 15 over 2. Question number 20. The centre of a circle is the point with coordinates minus 1, 3. The point A with coordinates 6, 8 lies on the circle. We have to find an equation of the tangent to the circle at A in the form ax plus by plus c equals 0, where a, b and c are integers. Here is a diagram. We've got a circle with the centre, and what we want is the equation of the tangent. We want the equation of the tangent. And what we can do is begin by finding the gradient of the radius and recognizing that the radius and the tangent are perpendicular to each other. So, the gradient of the radius then, we've got the change in y, 8 subtract 3, of the change in x, 6 subtract -1, So it turns out that the gradient is 5/7. So the gradient is 5/7. The gradient of the tangent is the negative reciprocal of this, which is 7/5. And so, using y equals mx plus c, we therefore have y equals minus 7/5x plus c. So, if we substitute in the point 6,8, we have 8 equals negative 7/5 times by 6 plus c. So, if I multiply through by 5, we have 40 equals minus 7 times by 6 plus 5c. 40 equals negative 42 plus 5c. And so 5c equals 82, which means c equals 82/5. And knowing what c is, we can therefore conclude we have y equals minus 7/5x plus 82/5. So we've got 5y equals minus 7x plus 82. And that's if I multiply through by 5, which means that 7x plus 5y minus 82 equals 0, which is the equation of the tangent in required form. Question number 21. The diagram shows 3 circles, each of radius 4 centimeters. The centers of the circles are A, B and C such that ABC is a straight line and AB equals BC, which is 4 centimeters. We have to work out the total area of the 2 shaded regions in terms of pi. First of all, we can find out the area of this sector here. Now, the key is in this question to realize what we have are 6 equilateral triangles. And so therefore, this angle here is 60 degrees. So the area of the sector then is equal to 60 divided by 360 times pi times by the radius squared. The radius is 4. And if we work this out, what we end up is 8 pi over 3. So we have 8 pi over 3 centimeters squared for this shaded region here. And then what we can do is we can find out the area of one of these triangles. And if we find out the area of one of those triangles, we can then find out this tiny bit over here. So the area of the triangle then, we've got 1/2 times by 4 times by 4 times by the sine of 60 degrees. So what we end up with is 4√3 centimeters squared. And now what we can do is find out the area of this shaded bit. Now, This will equal the area of the sector subtract the area of the triangle. So we have the shaded bit equaling 8 pi over 3 subtract 4 root 3. And then we have the units of centimeters squared. Now, what we can also do is find out the area of a full circle. The area of the circle, now we've got a radius of 4, that will equal pi times by 4 squared, which is 16 pi centimeters squared. So what we need to do is find out the area of the shaded region. So the way to think about this is to think, well, what we have is the entire circle take away the sectors which appear 4 times. So we've got this, 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 and this. And then we've also got these bits in between, which we also need to take away. So we've got 4 of these bits plus 4 of these sectors. So we've got 4 of those sectors and 4 of these shaded bits, which we need to subtract from the entire circle. So the shaded region, we've got the area of the entire circle, 16 pi, and then I need to subtract, well, what I have is 4 times the area of this sector. So I've got 4 times by 8 pi over 3, so that sector appears 4 times. And then I've also got the area of the shaded bit as well, which is 8 pi over 3 subtract 4 root 3. So I have 4 multiplied by 8 pi over 3 subtract 4 root 3. So this is what the shaded area is equal to. So I've got 16 multiplied by, now here, if I work this out, I have 32 pi over 3 subtract, now here I have to subtract 32 pi over 3, and then the minus 4 times by the minus 4 root 3, that will be positive 16 root 3. Rather, this is plus. So it's going to be minus. Now, these terms cancel out. So what we end up with then is, rather here, this will be a plus and this will be a minus. What we end up with is altogether, well, let's rewrite the 16 pi as 48 pi over 3. Then I'm subtracting 32 pi over 3 and another 32 pi over 3, so that will be the same as subtracting 64 pi over 3. And then I'm adding 16 root 3. So the required area is 16 root 3 subtract 16 pi over 3. So that is my required area.